Hello everyone, and welcome back to another mathematics and GIS tutorial video. In this video, I want to talk about how we can graph an ellipse that is not centered at the origin. And what I mean by that is I mean that its standard equation looks something like this. And if we go back to the previous example video where we graphed the one that was centered at the origin, you'll see that there are a couple of differences here. Specifically, the inclusion of the +2 here and the -5 here. And those are related to the h and k parameters that we've talked about in previous videos. So a couple of things that we know just right off the bat. Again, because we have these extra numbers in the numerators, we know that we're not centered at the origin. And because the larger value is under the y, we know that this is a vertical ellipse, meaning that it's going to be taller than it is wide, meaning that the vertices are going to be in the y direction. So what does this mean? Well, first we have to deal with h and k, which are, again, the coordinates of the center. So h is going to be, in this case, -2, right? Because the default here would be x minus, right? The standard equation is actually x minus h. So if there's a plus here, that means that h is negative. So that means h is going to be -2, and k is going to be 5, right? I'm just pulling these out of the standard equation, right? Y minus k. So h is -2, and k is 5. So that means we have our center, right? Our center is going to be -2, 5. And this is, again, just the definitions that we've went over in previous videos. So let's go ahead and plop 1, 2, 1, 2, 3, 4, 5. All right, so this is our center. Okay. So the next thing we need to consider are our vertices and our co-vertices. So our vertices are derived from the, if you remember back, our vertices, let's use blue, right? Vertices are derived from that a parameter, right? And specifically because we are not centered at the origin, right? Because we're shifted from the origin, right? Our vertices have the coordinates h, right? Because they're going to all have the same x. And then for y, it was a plus k, and then it was h and k minus a. Right, and if you're confused where I'm pulling these out, again, we have a video outlining the relationships. You can go back and watch that one if you're particularly confused. But again, we're just sort of relating the vertice positions to a and k, which are things that we have in the standard equation. So we have k. We know that a is going to be the square root of the larger of the two numbers. So we know that a squared is equal to 9. Sorry if my a's and my 9's look similar. We know that a squared is equal to 9, which means that a is equal to 3. So if we go back up here, we have a plus k is going to be equal to 3 plus 5, which is going to be equal to 8. So we know that this is going to be equal to -2, 8. And then we know that this one is going to be equal to -2, and then k minus a. So that's going to be 5 minus 3 is going to be equal to 2. Sorry, I should do k minus a is equal to 5 minus 3 is equal to 2. Okay, so our vertices are going to be -2, so -1, -2, 8. 1, 2, 3, 4, 5, 6, 7, 8. And -2, -1, -2, 2. 1, 2. And just a quick gut check at this point. We know that the center should be the midpoint between the two vertices. So just in case we somehow did something wrong, right? 1, 2, 3, 1, 2, 3. So we're fairly confident that our vertices are in the right place. So now let's talk about co-vertices. Right, so that was vertices. Right, our co-vertices right, these are going to rely on that b parameter. These are going to rely on b. So again, b is going to be related to the smaller denominator up here, which in this case is 4. So we know that b squared equals 4, which means that b is equal to 2. And again, all I did was pull down the correct parameter, take the square root. So hopefully you're able to follow along with that. Similarly to the vertices, right, our co-vertices can be written in terms of h, b, and k. And again, if where I'm pulling these out from confuse you, we have a video that outlines how these things are related. So we know that the co-vertices, right, these are going to be in the x direction, right, have a value of h plus b, k, and a value of h minus b, comma k. Right, it looks similar to this up here, except we switch the x for the y. So we know that our b is 2 and our h is -2, so we have -2 plus 2 is going to be equal to 0, and we know that -2 minus 2 is going to be equal to -4. So we have, this is going to be 0, comma 5, and this one is going to be -4, comma 5. So if we go 0, so we don't go anywhere on the x-axis, and then we go 5 up, goes right there. And then if we go -2, -4, 5, and again, just to kind of gut check, 1, 2, 1, 2. So our center really is the center between the vertices and co-vertices. Now all we have to do is go ahead and connect these up. Again, you connect the vertices in an arc through the co-vertices. Something like that. Now I know whenever I do this, I always tend to look like a football, but if you were to use a graphing software, it would look much more precise. It's going to look something like that. And again, you can see that it is actually longer than it is wide. So hopefully that made sense. Again, if any of this confused you, go back, please watch the parts you're confused about. And as always, please reach out. Thank you.